Sometimes we apply what we think are performance best practices onto our page, but in reality, it can actually make performance worse. I'd like to talk to you a little bit about this demo where lazy loading is being used on an image which probably shouldn't be lazy loaded. But rather than just tell you it shouldn't be, I want to prove it to you, and I want to show you how we can interpret network request waterfalls to determine that, yes, indeed, that probably shouldn't be lazy loaded, and make sure we can see the before and after effects. Before I show you the actual demo, I just very quickly want to show you how lazy loading might be used correctly. Here I've got a page, and if I skim through the DOM tree, you'll see it's pretty much a bunch of paragraphs, then an image, and the key part here is that all the images have loading equals lazy, and you can see that the images are below the fold. In fact, I can scroll down so you can see them, but then I'll scroll back up and I'll reload the page in the network panel so you can see what's happening. I'll hit reload here, and you can see, all right, fair enough, the browser decided to download some of the lazy loaded images, but if I start scrolling, in fact, we can clear the recording. I suspect there are some that haven't downloaded. Yeah, there were a few. As those images got closer to the viewport, the browser said, now it's time to download it. Makes sense. Now back to the demo that I really want to focus on and work to making very subtle improvements. Let's start by comparing the page to the HTML source. We've got the page, and that page has a style sheet, so a render blocking style sheet, and it's delayed by 500 milliseconds just so it helps me better demonstrate things. And after that style sheet has downloaded, we've got a bunch of embedded styles which are not important for this demo. We've got the H1, which is over here. We've got an image, and this image is loading equals lazy, so it's a lazy loaded image, but it's above the fold, and it kind of raises some questions as to whether that's useful or not, or rather, does it actually have any negative impact? And then under that image, there's also some paragraph tags, which are here. If we navigate to the network panel and reload the page, we'll see the request waterfall of how this page comes into existence. And one thing that stands out to me very clearly is that the image, which is the third resource in this waterfall, is being downloaded after the CSS style sheet, which is unfortunate because normally browsers are very optimized at being able to download things in parallel. It's a great benefit of how resource downloading on the web actually works. You want things to be downloaded in parallel. In this case, that's not happening. I can't give you the full set of reasons as to exactly why this is happening, but I can make an educated guess that it might be connected to the fact that the browser might be wanting to see if the image is in the initial viewport potentially, and maybe to do that, it needs to download the style sheet. It could also be that the loading equals lazy sort of sets the priority of the image to a low priority, and maybe the browser doesn't think it's important to download right now. And by right now, I mean during the download of the style sheet. Regardless, let's see the actual effects of this. If we go on over to the performance panel, I'll hit this icon, which starts profiling while it reloads the page, and we'll see a little bit what that looks like. Now, in the performance panel, there are rendering milestones, and those milestones might be DOM content loaded, the load event, first paint, first contentful paint, largest contentful paint. And this is the important metric that I want you to pay attention to. It turns out that the largest contentful paint happens to be the image in this case, and we can confirm that by hovering over, and you see it highlights the image, but you can also drag this drawer up and it will tell you the related node in question, which is definitely the image tag. You see, largest contentful paint is one of the metrics of Core Web Vitals, and having a poor LCP score can actually contribute to a poor overall Core Web Vitals score, which can have other unfortunate side effects, such as maybe it affects your page ranking and so on and so forth. I'm not trying to suggest that by fixing a potentially poor LCP score, you end up jumping to the top of the search results. But at the end of the day, this stuff does impact our users, so we should strive to fix it. Just to clarify once more, before I move away from this performance panel recording, we've got the document. That's the document resource in the network track. We've got the CSS file. And then after that CSS file is downloaded, only then is the image actually downloaded. We can click on that. We can go to the summary, and it kind of gives you some interesting information. Turns out it had an initial priority of low, then it turned into high. And in case you didn't know, yes, requests on the web from a browser do have these request priorities. And this is especially useful because when you have a page that has a lot of resources, a low priority request might struggle to sort of compete with a high priority request. If you want to follow along with this demo, I highly recommend you come to the DebugBear free website speed test, and you can chuck that URL directly into this input box and just click Start Test. The URL is over here, so feel free to try that out or just continue watching. In this case, I'm going to be using our paid offering to run the report, which has some extra features and works a little bit differently. But again, to follow along, the website speed test should generally be satisfactory. Back to the actual report. We ran this in a desktop environment. There was a bit of network throttling, and we have a lab score, which definitely factors in things like cumulative layout shift, which we haven't spoken about yet, but we will do later on in this video. And there's that largest contentful paint, which is not ideal right now, so let's work to improving that. In this report, there's a handy film strip, and we highlight very clearly for you the actual image within the film strip that represents the LCP download, and that's right here. We also show a video recording, which is pretty nice. And if you scroll back up and click on the largest contentful paint metric, by the way, I'm very zoomed in for the sake of a video, that's why things are looking a bit truncated. But if you click on that largest contentful paint metric, we show you the exact image URL which contributed to that LCP. And remember, sometimes it might not actually be an image that is the LCP. In this case it is, so we can show the URL. We show at what point in the timeline did it start downloading. We show how long that download took, and remember there was an artificial delay of at least 1 second there. And we show that the request priority was low. I can also click on the dedicated requests view and open up that image, and there's a few interesting things that we highlight here. We indicate through these badges that this was a lazy loaded image, and funnily enough, we give the recommendation, don't use lazy loading for a high priority resource like LCP images. We can open up this request and we get a bunch of interesting information here, some of which you could probably have guessed, some of which might be sort of interesting, like it did end up being a high priority request, but it started out as low. And again, in this simple demo, it might not be the biggest issue, but it definitely can be an issue when requests are actually competing or contending for bandwidth. And in terms of that priority change, it's very subtle. I'll zoom in within the video, but that red vertical line within the sort of long rectangle, that indicates when the priority actually changed. All right, great. We've seen a bunch of interesting little bits of information, but I think it's time to get fixing. I would love to be able to just remove loading equals lazy, but this is DevTools, and when I reload the page, my changes are going to be lost, I think. Well, not necessarily. If we open up this sidebar and go to the overrides pane, you can enable local overrides. I've already added a folder which is simply on my desktop. And what happens now is if I go back to the sources panel and I just add a few exclamation marks, I hit Command S, you see that there's this little purple indicator that explains that DevTools is now sort of overriding this production website with this local file on my file system. And reload the page to confirm. There you go, there's the exclamation marks. I'm going to get rid of those, it's not important for the demo. What I will also get rid of is the loading equals lazy. We've gotten rid of loading equals lazy. It's time to go back to the network panel, reload the page. I don't want you to memorize the potentially flawed idea that removing loading equals lazy automatically means resources are now downloaded in parallel, as opposed to sequentially, one after the other. Because again, it really depends on a number of heuristics. It depends on other things on the page, but in this case, it did seem to help with our demo. The image is now downloaded in parallel with the style sheet, and that's a massive improvement. While it's helpful to visualize in the network panel, I want to kind of verify this with hard numbers in the performance panel. So I'll hit this icon to reload the page and start profiling. Drag that summary pane down, and straight away I can see for sure that image resource, which is what I'm hovering over right now, is definitely being downloaded in parallel with the style sheet. And if I click on the actual image in the network track there, that's kind of interesting. The priority does end up being high, but it started out with a medium priority. So maybe that's a little thing to look at next. Here's the result in DebugBear. You can see that lab score has improved a little bit, but the actual largest contentful paint time, I can't remember if that's improved or not, because I don't remember the previous times. I guess if I click on that, will it sort of give me a clue of what's changed? No, because this is entirely focused around this run, which happened after I removed loading equals lazy, so it's a bit hard to really judge the fix. This is where the compare feature really shines. I've got a compare URL in my clipboard, so I'm going to go straight to that, and it will compare the version, which is this previous test right here. It will compare that, which has the loading equals lazy, with a version that does not have loading equals lazy, aka our first fix, or our first improvement, maybe that's a better term to use. Here it becomes a lot more evident that yes, we shaved off like half a second from that LCP time, the LCP metric, and if I click on that, it gives quite a nice sort of screenshot comparison between the two. But if we scroll down, we can see for sure the LCP request start time, because it's now being downloaded in parallel with that style sheet, it's happening a lot earlier. That's really good. Unsurprisingly, the actual time it takes the image to download, that's very similar. That hasn't changed. And also kind of interestingly, the request priority, there's something going on there. Let's talk about that in a second. And just very quickly, if I scroll to the bottom, I think it's videos that make this really easy to digest. There we go. It happens a bit fast, so we can step through frame by frame. This screenshot, I think, perfectly highlights the fix or the improvement that we just put into place. The comparison view is really ingrained in everything you look at when it's enabled. With the comparison view enabled, I can actually go to an individual request and it will show all the different headers or the different fields that have really changed. And that's very useful. In this case, the thing that kind of piques my interest, if you like, in the unfixed version, it started out as low, graduated to high. In the fixed version, it started out as medium and graduated to high. So let's see if we can fix that, but there's just two more things I want to mention to you. If I go back to the original problem version, this is where loading equals lazy was being used for the LCP image, and you scroll all the way to the bottom of a DebugBear report, we show this recommendation. And the recommendation says, ensure the LCP image is loaded with high priority. First of all, I love that we're showing these recommendations so you don't have to digest the entirety of what could be a somewhat complicated report. But what I also really like is when you open this up, we give you a almost one-click run button where you just click run experiment, and we'll double check with you that you definitely want to add this code in. This won't add code to your actual website. It's not connected to your production website. This is to test and compare the before and after. In this case, the experiment is around adding link rel preload, which actually adds it to the head of the document. And this is totally suitable to do, by the way. I don't think there's anything wrong with this. And you could argue that the preload scanner would actually catch that really early on and start downloading this resource, again, very early on in the page load process, which for the sake of an LCP element, that's a good thing. You can run the experiment by clicking run experiment. And when you do, you get something that looks a little like this. So it's very similar to what you just saw. There's the baseline and there's the experiment. And I think it's quite helpful to use the video as a comparison. There we go. You can see that almost one-click experiment version, which is shown on the right side. That gets the image way earlier on, and we just get a better LCP time overall. However, I really want to focus on one of the interesting attributes that was shown in this experiment. It's fetch priority high. Turns out you don't have to reserve that for link rel preloads. We can actually copy this and use this on the image without having to use a link rel preload in the first place. And that might help with the fact that the initial priority previously, it started out as medium, which again, in this simple demo doesn't really matter, but there are times where it could make a big difference. Since we've got DevTools overrides working, all we really have to do is jump into the sources panel, add that attribute and attribute value, fetch priority equals high. I just hit save and I'm going to reload the page. In fact, let me do it from the performance panel. And let's see if that priority, at least the initial priority, changed at all. Okay, so not much has really changed, but if I click on that image resource, There we go, initial priority of high, and it also ended up being a priority of high, which was happening already. Let's use the debug bear comparison view to actually see the differences. You can see the lab score hasn't really changed, so don't get me wrong, this is a very subtle improvement. And you could argue that for the sake of this simple demo that doesn't have a lot of resources on it, there's not really much of an improvement, but still, it's the education that we want to convey in this video. Now the baseline, aka the previous test, that's the one with loading equals lazy being removed, but no fetch priority attribute on the image tag. And then the current test is fetch priority high added to the image. So not much is really changing. I suspect the video is going to look near identical. It does. But if we go to the request waterfall view, you can see straight away there's a badge and it actually says fetch priority high new in parentheses. So that suggests there's been some sort of change. And if I scroll down, there we go. So previously the red text, it was high, but it actually started out as medium and it only changed after almost a second. That late shift in the priority change is not ideal. And I know I've said this a lot of times already, but it really can make a difference when resources are competing for one another in terms of bandwidth. And maybe you've got a bunch of other scripts in the head or style sheets. This is where it comes into play. Now, finally, I just want to focus on one more potential fix we can put in place here. You might have noticed in this main performance panel area where it has these different tracks like frames, timings, layout shifts, main. Like layout shift doesn't sound good, and you might know that cumulative layout shift is actually one of the metrics part of Core Web Vitals. So if we can improve that, I think that would be pretty good. The layout shift is actually identified right here, and you can click on that, and it's pretty nice. It will give you a score. In this case, the score is not that bad. Again, it's a very simple page. And it will show you these sort of coordinates for how elements on the page moved, which I always get a little bit overwhelmed by. I never really know what to focus on when I'm looking at this. And it highlights the actual paragraphs that were impacted. But what was the layout shift? If we scroll through the film strip, you can see the layout shift directly at this point in time. At this moment, the browser did not know the dimensions of the image, so it couldn't reserve space for that image. And at this point, the browser did know the size of the image and it had finished downloading that image. And then it just kind of shifted things out of the way. You see, the web is somewhat progressive by default. It will attempt to render web pages even if not all the resources are finished downloading. In this case, it can actually harm the user experience because yes, they got the text early, but if you're like me, you start reading and suddenly the text shifts out of the way suddenly and it can be a bit jarring and a bit frustrating. Now that explains the layout shift score, but let's see what that looks like in Debug Bear. Over here, you can actually click on the cumulative layout shift metric. And I'm a big fan of this view because we highlight for you very clearly what has actually shifted. And we give you the sort of human readable explanation. Position change, down 400 pixels. That's quite easy to understand. And I find this a little bit easier to read than the sort of coordinates that we were seeing previously. But the truth is, I think Debug Bear can actually complement DevTools very nicely, and they should ideally be used together as part of a performance investigation workflow. The report confirms to us that there is a layout shift. We can also go to the lab score, which, to be honest, the layout shift is so subtle, it doesn't really seem to have a significant impact, but there is a little bit of CLS being factored into that lab score. But let's get into fixing. I will close this and close that. We basically want to tell the browser up front how much space should be rendered. We don't want to hard code some pixel values, so we can use the CSS aspect ratio CSS property. How do we know what the CSS aspect ratio should be? We can hover over the image in the elements panel, and you see we get this rendered aspect ratio and intrinsic aspect ratio. It will ultimately depend on your use case in terms of how the image should really be rendered. In this scenario, I'm happy with an aspect ratio of 2:1. And as usual, we're going to go back into the sources panel and just make our change right here. Style equals aspect ratio. That's nice that you get auto suggest even in a inline style attribute. Of course, I'm doing this for the sake of a demo, by the way. This sort of stuff I would typically add in a style sheet, but there's the aspect ratio. And just to be safe, width of 100 and height of auto. Hit Command S to save it and see if, regardless of the performance panel, see if you can actually see any change on the page as the page renders, but before the image loads. I don't know about you, but I did see, I think, a bit of reserved space for the image there. And there it is. We can confirm in the screenshots that indeed the browser did reserve the adequate space because we specified the aspect ratio up front in the HTML source code. And that's worked out pretty nicely. Sometimes it can be a bit unclear whether or not you actually fixed the layout shift. What I would recommend you do is just look for a layout shift track. If the track has disappeared, there were no layout shifts in the performance panel recording that you made, and that's what's happened here. The layout shift has just totally disappeared. If I go to the previous recording, there's the layout shift track and there's a layout shift event. Current recording, no layout shift track. Let's double check what that looks like within a DebugBear comparison report. Indeed, I can see that the CLS has been removed in the comparison view, but one thing that I just find a lot easier at times is to use the video recording just to verify that the change has been applied. And there it is. The browser has indeed reserved the space necessary for that image, meaning no layout shift actually happens. Okay, and that's pretty much all I wanted to show you. Let's do a very quick recap. To start out with the original problem that we had, our main LCP image was being lazy loaded, unfortunately. And there was this funny effect where possibly, again, don't quote me on this, but potentially the browser was waiting for the style sheet to download because it wanted to see, was the image actually in the viewport, and only then was it downloading that image. Typically, browsers are able to download images in parallel with style sheets, even though style sheets are render blocking resources. In the problematic version, the request waterfall looked a little bit like this. Not ideal. We then simply removed loading equals lazy, and the request waterfall looked a little like this. However, that red vertical line within this rectangular bar represents a priority change. It means that the resource actually started out as a medium priority, which is the default for images, and turned into a high priority, which again isn't bad for this demo, but when there are other resources being downloaded and it has to contend with other things in that critical rendering path, that can become a problem. Since we know that this is an important image and we know that this is also an LCP image, we actually added the fetch priority high attribute. And if we go into the request view for that fix, there we go. In this instance, there was no initial priority that was different. It was just high all along. And we highlight that with the FP equals high badge in the request view. Finally, and somewhat unrelated to these sort of request priorities that we've been discussing and lazy loading, there was another issue of cumulative layout shift, where the browser didn't really know the dimensions of the image it was downloading because the image hadn't downloaded yet. As a result, it didn't really reserve much space. And when the image finally did download in, it shifted the text that was meant to be below that image. It shifted it out of the way, and that caused a layout shift. We fixed that using the CSS aspect ratio property, and we ended up with a cumulative layout shift of 0. And remember, you can actually try all of this out by going to this demo. I'm going to delete the overrides that I've been applying. And if I reload the page, we can see those problems return because I haven't applied those fixes permanently in my actual source code. Please do try this out. You can, by all means, use the DevTools overrides feature, which I think is perfect for this. And a little side note, you might have been wondering, why would someone put loading equals lazy on an LCP or on a main image above the fold? But that's a fair question. However, I can tell you, having done these sorts of performance investigations for a while, this does happen. It could be because there's a performance plugin that kicks in and automatically applies loading equals lazy to all images, or it could be something as simple as the CMS that you're using. Maybe it's WordPress, or maybe it's a plugin within WordPress. As you upload images and it inserts it into your page, maybe it just applies loading equals lazy, and there's a little setting you can use to put that off. Whatever it is, and whether or not you actually have websites being affected by this issue, the point of this video was to demonstrate and showcase some performance workflows you can use, from using the network panel to the performance panel, and showing you a little bit about what DebugBear looks like when you run those same pages through our website speed tests. That's it for now. Thank you for watching. See you next time.